print this out, I would like to quickly go over some exponential notations, just a refresher. If you would like to pick, because you're going to have to work on the other ones. So maybe that will be your very first assignment for Wednesday. Anyone would like to pick from these?
E, please.
E. So in E we have 2x to negative 3, y squared, everything raised to negative 3. Okay. Good. So remember, whenever we work with exponential notations, the final answer must be a fraction. If it has negative exponents, we have to change them so that the final answer does not have negative exponents. Then we consider the answer fully simplified. Okay, anyone would like to give it a shot on how we start on this? Everyone will answer a question for the rest of the 25 minutes. Okay, let's start with Alex. Alex, can you give me any idea? Do not feel picked on. Do not feel that everyone, as I said, will participate and engage.
It's all right. 1/8 first, right?
So what would you do here?
So 2 to negative 3.
Excellent. Thank you very much. And then x to negative 3, everything to the third. And then y squared to negative 3. Perfect. Next, Noor. What do you think is the next step? In this way, I know what you know, and you know what you know, and I know what I need to do. Are you there? I'm listening.
Hear me?
Yes, I can.
Oh, okay, sorry. I wasn't sure. I haven't taken a math course in a while, so I apologize.
No worries. That's why I'm here. That's why we're here.
I don't have my calculator on me, so I apologize, but do we,
Just tell me what you would do next.
Would we solve for like 2 to the negative third and then solve for the exponents?
So
next?
we will leave 2 to negative 3 as is.
Okay.
And now we will copy the base. And what do we do next?
Excuse me, I have a question.
Any question?
The exponent after the x to the negative 3, is that supposed to be positive 3, or is that?
Thank you. I talked too much. My apologies.
No worries. The rules of
Absolutely. With the moment I would, yep, absolutely. As I said, I'm sorry. I have to apologize from the very beginning. I know I talk too much. But it's all in good faith.
If it's negative, doesn't it all go into like a fraction over?
Not yet.
No.
So we have a base raised to an exponent, and the whole thing is raised to another exponent.
You would multiply the exponent.
Thank you very much. X raised to the 9th power. And y to which power?
Negative 6.
Excellent. Very good. At this point, yes, we have 2 exponential notations with negative exponents and 1 with positive. What happens next? Okay, let's say Gabby. Are you there?
Yeah, sorry.
No problem.
I don't know.
That's okay. So we have x to the 9.
Now your turn's gonna be.
Yes. Any exponent with a negative any exponential notation with a negative exponent changes into a fraction. So therefore, these 2 go to the denominator as 2 to the 3rd and y to the 6th. And of course, let's say, Lake, can you tell us what we do next?
You bring 2 to the 3rd power.
Excellent. Great job. 8y to the 6th. Perfect. So this is about exponential notations. So you're going to have to work on the other ones. Is there anything else you would like to work on now, or we move on?
We're just doing number 1.
So far, because I want to go back to this to finish this after number 1. And the rest we're going to get to, of course.
Can we do A whenever it's a fraction to a negative exponent?
Very good. Okay, so we have 2/3 raised to -2. Anyone has an idea about this?
Would it be just split it and then the square?
Very good. So I think you said this. I couldn't really hear. So when we have a fraction to a negative exponent, we flip the fraction and the exponent becomes positive. Very good. So if I mispronounce your name, please forgive me. Okay, Amin. What do we do next?
I'm not sure.
Okay, we raise 3 to the second power and 2 to the second power. Michelle?
So 9/4.
Great job. Good. Moving on. I'd like to continue with this. This is something that I just want to joke with my students in a way, but maybe, hopefully, they will remember this forever. So I say it's valid forever. This is our first day agreement. I don't want to go back. I want us to move forward together. So I want these to be carved in stone moving forward so we never get that question, how come that this or that? Okay, anyone remembers what a plus b to the second power equals to?
Would be a squared. 2ab
Very good.
plus b squared.
Excellent. So please remember this. If you have any doubts, this is the time to ask. Hopefully we don't have to move forward without understanding this. Is it Haber or Haber? How do I pronounce your name? Forgive me. I couldn't hear one word.
Oh, sorry. It's Haber.
Haber.
Would you start by
Do we understand this? Do we have any questions on this?
no?
No. Okay, what about 2x plus 3y squared? Can anyone give us the answer? We don't want to FOIL. We're going backwards if we FOIL. Very good. 4x, if you want to write it like this, that's fine. Plus 2 multiplied by 2x and multiplied by squared, right? And then plus, let's say Savannah.
Would it be the y squared?
3y squared squared. So let's analyze this. So it means that it's not clear. This is the first term. This is the second term. And you have to follow the pattern. The first term squared plus twice the first times the second plus the second term squared. This is what we did here. We raised the first term to the second power. Oops. The first term to the second power plus 2. I'm not used to writing like this, but I want to write it the first time like that. So 2 times 2x, 2 times the first term, which is 2x, times the second term, which is 3y squared, and then plus 3y squared, which is b squared. Do we all understand this?
Yes.
Okay, is it Rita or Rida?
Rita.
Rita, very good. Okay, can anyone, since we already worked on exponential notations, can anyone give us the simplified form of this? Okay, would you like to start, Rita, please?
Okay, so it would be 4x squared plus
So let's
12xy squared
exactly 2 times 2 times 3. Excellent. 12xy squared and plus.
plus 9y to the 4th power.
Excellent. Good. So this is done. We move on to the second one. Obviously, there is no problem here. What is the only difference? It's right here. That's the only difference. Everything else is the same. So this is a squared minus 2ab and plus b squared. And we get the pattern is the same. Are we okay with this? Everyone, please. Jackson?
Yes.
Yes?
Yeah, yes.
Okay, very good. We need another example with the one with minus, or we move on to the last one. Okay, so the last one, notice that is not the same, right? These two are pretty similar. What is the only difference is the plus and the minus. But what about this? And no, we don't want to FOIL. So this is the difference of squares. Difference of squares. Anyone would like to say anything?
Can
Who?
I say what I think the answer was?
Yes, absolutely.
Would it be a squared minus b squared?
Very good. So remember, this is another pattern. These two factors have to be identical except the signs. So let's look at an example. Let's say 5x minus 2 and 5x plus 2. Okay, let's say, is it Zainab?
Yes, Zainab.
Zainab. Am I correct? Can you say it again?
Yes.
Zainab? Zainab?
Yes.
Perfect, thank you. Would you like to try?
Okay. So it would be 25x squared
Excellent.
minus 4 squared minus 4.
Done. Very good. Well done. Okay, so now we can come back. Why I needed to do, or I wanted to cover this right after this, simply because it deals with exponential notations. And now we can continue with the review. Okay. So let's take a look at, you may not be able to see, so factor completely. Let's choose something from there. I'm sorry?
Oh, I said D.
Okay, you said D and then I said E. So let's do D. D is mainly the most difficult one. My page 2 plus 11x minus 6. I am not very fond of problems like these because we have easier methods. So, however, the reason why I'm not very fond of it is because the number that we're going to create in a minute is a big number. But it's okay. So in this situation, first I have to make sure that everything, yes, if you want to say something, please go ahead. Okay, so this is a polynomial that is called trinomial. I want to show this one of the methods. You may have a different method of how to factor this. Some calculators even factor themselves, but you still have to work the problem out and you have to show work. So please don't skip steps, I would say. So it's a trinomial and it's in descending order. Very important, x squared, x, and no x. And this is not a perfect square. And this is not a perfect square. So what? What does that mean? Well, if this is a perfect square and this is a perfect square, here's my prop. Going backwards, I say, well, I expect this to be 2x plus 3y squared. Is this good? It's very good, but it's not good enough because I have not checked the middle term. If the middle term of this expansion is not 2 times 2x times 3y squared, then I cannot factor. See, when we go from this to this, we expand. When we go from the expanded form back to this form, we factor. So expanding, factoring. So my first concern is this a perfect square? Is this a perfect square? No, because I like to use one of these formulas. Either this or this, but I can't. Secondly, the leading coefficient has to be 1 in both situations, which is not. Do these three terms have a common factor? No, they don't. 15, 11, and 6 don't have a common factor. And the leading coefficient is not 1. What can be done? I can try to find two numbers whose product is this. This is the product. But 15 times negative 6 is negative 90. This will always be the sum of the numbers I'm looking for. Same numbers. So now the question is, and I'm asking you, can I find two numbers whose product is negative 90 and whose sum is 11? Remember, we start from here. If this is a negative number, when I multiply two numbers to get a negative number, it is mandatory to say or find a positive and a negative. So can anyone give us a positive and a negative number whose product is negative 90 and whose sum is 11?
10 and 5.
You said 10 and 5?
Or the 15. Never mind, I think I misunderstood your question.
Okay, so what I'm saying is we have to find two numbers whose product is negative 90. So obviously one has to be positive and one has to be negative. So such that when we multiply them, we get negative 90. When we add them, we get positive 11. So let's start with negative 90 or just 90. Is there any way I can present this in factored form? Yeah. First of all, I'll say 9 times 10. Then I will write 3 times 3. And then 2 times 5. So these are prime factors. Prime factors. What do I need this for? So I'll put them in ascending order. I will not write 3 squared. We normally don't write this. We write 2 times 3 squared times 5 is the factorization, the prime factorization of 90. But the reason why I put them like this is because it's easier to come up with two numbers whose product will be negative 90. Of course, this number has to be negative, and whose sum is 11. If it exists, if we can find two numbers whose product is negative 90 and whose sum is 11, then this is not factorable.